Curve is given by this function here with a single turning point at x equals alpha. Let's show that alpha is a solution to this cubic equation. So for the turning point, we need to look at f dash x, or dy by dx. Differentiate this, I'm going to get 2x plus. Now I'm going to use the chain rule on ln 2x squared minus 4x plus 5. So the quick way to do this is to differentiate the outside, which ln is just 1 over. So it's going to be all over 2x squared minus 4x plus 5, and times by the derivative of the inside, which is going to be 4x minus 4. And we can just put it straight as a fraction like this. If you're not happy with that, then I'd say like definitely practice it, get used to doing it's called the inside outside rule. But let's just backtrack and do it the long way. Because it also gives insight into why it works. So the long way would be to let u equal 2x squared minus 4x plus 5. And then dy by dx is actually, by the way, that's the same as f dash x, dy by du, du by dx. So because I've let u equal that function of x, then y is now going to equal ln u. And dy by du is 1 over u. See, that's what I mean by doing like the outside. It's just ln. We get 1 over whatever the function is. That's where my 1 over 2x squared minus 4x plus 5 came from. And now I'm timesing by du by dx, which is the derivative of the inside. So we get 4x minus 4. And if we bring that together, it's going to give us the answer I showed you really quickly. Technically, I should put a bracket around that. So this is then equals 0 for the turning point. And now I'm going to multiply through by 2x squared minus 4x plus 5. Okay, expand the bracket. I could actually divide through by 2 right at this point, or I could do it at the end. I'll do it at the end, I think. 4x cubed minus 8x squared plus 10x plus 4x minus 4 equals 0. Okay, simplify it to that, and then divide through by 2 now. 2x cubed minus 4x squared plus 7x minus 2 equals 0, as required. An iterative formula is used to find an approximate value for alpha. So what has happened here is we've rearranged to make this x the subject, and then you can use fixed point iteration, which is a method where you just very quickly going to draw it. You have y equals x, and you've got like your function, and then you start off with a value, and you can converge towards where y equals x intercepts your your other function. That will give you the root of the original equation. It's pretty amazing numerical method, because although we could solve this exactly in theory, I don't think it's going to have cubics can be solved exactly, though I don't think we can use the factor theorem here to do it. So this question's getting us to do it numerically. In any case, here we just have to substitute 0.3 in. So it's actually quite nice. All right, so let's put 0.3 into our calculator as our answer, because we're going to be doing this multiple times, and then just replace all of the xn's by the answer button. So 0 point, it's 4 decimal places, 0.3294. Then this is x3 and this is x4, so 0.3398. You could write your x3 down if you wanted to. When I originally did it, I did that. I always like to just keep track. Okay, that's it. That's our answers to 4 decimal places. You might want to write them to more and then round it. That maybe, but I'm confident they're okay. Then using a suitable interval and a suitable function that should be stated, show that alpha is 0.341 to 3 decimal places. Okay, that's pretty, that's confirmation really that our earlier answer was correct. So we need to abandon the iterative method at this point and use the sign change rule. So I'm trying to show that it's 0.341 to 3 decimal places. So I'm going to show there's a sign change between 0.3405 and 0.3415. Because if I can show it goes from positive to negative or vice versa, and the function is continuous, then it's got to be that the root lies between these values and hence would round. Well, I don't know where exactly it is, but to to 3 decimal places, it's going to round to 0.341, which is like here. So all of these, if the root was here, it would still round to 0.341. If it was here, still round to 0.341. Okay, it does give us a little bit of a hint. Find the suitable function. So which function are we using? It's actually not the original function. We're solving the cubic that arose from differentiating and setting it equal to 0. So it's this 2x cubed minus 4x squared function. Just going to bring it down. So I'm going to I'll call it g of x. And then I'm going to find g of 0.3405 and g of 0.3415. Okay, then just carefully type it in. And I get minus 1.305 times 10 to the minus 3. So less than 0. Okay, now I can just slightly modify this. Change the zeros to ones. Gives me 3.66 times 10 to the minus 3, which is greater than 0. Just have to write a conclusion now. So there's a sign change. One's negative, one's positive. And g of x is continuous. It's important that we say that. Okay, it doesn't like jump from being below the axis to above. It's continuous, so it's going to necessarily go through it. So there is a root between x equals 0.3405 and 0.3415. And therefore, alpha equals 0.341 to 3 decimal places. I'd go overboard. I know it's only 2 marks, but just make sure you hit all these key things. I think, to be honest, the key ones are, because only 2 marks, but getting like these values and then actually basically need to say there's a sign change or that one's positive, one's negative, say that it's continuous, and then write your conclusion. Well done.